differentiate the knocking phenomenon of SI and CI engines. We know that in spark ignition engine, knocking occurs when small pockets of air-fuel mixture combust due to auto-ignition outside the boundary of normal combustion front. Whereas in compressed ignition engine, knocking occurs due to instantaneous pressure rise in the combustion chamber caused by sudden combustion of large amount of fuel accumulated during the long ignition delay period. Despite the fact that in both SI and CI engines, knock depends on auto-ignition lag of the air-fuel mixture, there are very few key differences in knocking of both engines. The main parameters of these differences are time of knocking, auto-ignition tendency, intensity of knocking, and pre-ignition. Now let's discuss the differences one by one. In SI engine, the auto-ignition of gas at the end of combustion chamber leads to knocking. Therefore, knocking occurs at the end of combustion. After the peak pressure is achieved, this can be shown in the pressure time diagram as. Whereas in CI engine, the auto-ignition delay of charge at the start of combustion leads to knocking. Therefore, knocking occurs at the beginning of combustion, before the peak pressure is achieved. This can be shown in the pressure time diagram as. In SI engine, the auto-ignition tendency of fuel should be lower to delay the auto-ignition and thus prevent knocking. Whereas in CI engine, the auto-igniting tendency of fuel should be higher to rapidly start the combustion and avoid the accumulation of fuel and thus prevent knocking. In SI engine, auto-igniting mixture is homogeneous, which causes knocking of a very high intensity and high rate of pressure rise at explosive knocking. Whereas in CI engine, the auto-igniting mixture is heterogeneous, which causes knocking of relatively low intensity and low rate of pressure rise at explosive knocking. In SI engine, air-fuel mixture enters and gets compressed during the compression stroke. Therefore, pre-ignition can also take place. Whereas in CI engine, only air enters and gets compressed during the compression stroke. Therefore, pre-ignition cannot take place. The related terms are